this video is for my honors students only. General students, you do not need to worry about this. Please find a different video. So, honors kids, this video is about photon calculations. Remember from your reading, sometimes atoms will absorb some energy. And what will happen is that some electrons or an electron will get excited and it will jump energy levels to a higher energy level. At some point, that excited electron is going to want to kind of crash and go back to its ground state. When it does that, it releases the energy that it had absorbed in like kind of a packet, and that thing is called a photon. And we will see photon in the form of radiation, such as light, like microwaves, ultraviolet light, etc., the EMR. So we can do some math to determine the energy, the wavelength, and the frequency of the photon being emitted. So there are two formulas you're going to use in this unit. The first one is E equals H times V. E stands for energy, okay? And the unit we use for energy is joules. H is going to be a constant, and it's called Planck's constant. And this is just a number to make the math work. And it ends up being something, I believe it's 6.63 times 10 to the negative 34th joules times seconds. The last piece of this equation is your frequency. Remember, a frequency is how often a wave cycle happens per second, okay? And this unit is going to be something called hertz. Another way we could write hertz is doing an inverse second. So that's the first formula we use. The second formula we use is the speed of light formula. So right here, c is the speed of light in a vacuum. And this is also a constant number. We've scientifically found the speed of light is 3 times 10 to the 8th meters per second. Lambda is a funky one. This is a Greek letter talking about wavelength. So wavelength discusses basically how long or how big the wave is, the wave of light. Okay, and the unit that we'll use for wavelength is usually meters, although sometimes we're going to do it in nanometers. And then again, V is our frequency in hertz. So you can find, as long as you have two of the three variables in each equation, you can just solve for x. This is just basic algebra. If you ever do want to get yourself to nanometers, if you're trying to go from meters to nanometers, you're going to just divide your wavelength in meters by the conversion, which is 1 times 10 to the negative 9th meters. And that will get you into nanometers. Stay tuned for another video where I discuss how to do one of these calculations.